And now we're going to extend the number line. So here we've got, so this is the same idea as before. So we've got our x, which is our logarithm at the top, and our y, which is our normal number at the bottom. And this is the part that we were using before. So between 0 and 1 for the logarithm, or 1 and 10 for the normal number. And then we're going to extend it. So we know this is still in base 10. So we know that if the logarithm is 2, then the y value is going to be 100, because 10 to the power 2 is 100, so this is 1000 here. If the logarithm is equal to -1, then our y is 0.1, and then 0.01 back here. So now we're going to fill in some values to the right and left of this, the simplest part that we did in the previous video. Alright, so first of all, let's add a couple of things that we already know about. So we've got, so let's make all these red so that we can see them more easily. There we go. Alright, so first of all, so we know that if the logarithm is 2, so the logarithm of 2 is equal to 0.301. So I'm just going to put in a couple of known ones on here to begin with, and that the logarithm of 7 is 0.845. Okay, but then how about the logarithm of 20, for example? So we know that the logarithm of 20 is equal to the logarithm of 10 minus 2, sorry, 10 times 2, so that's the same as saying the logarithm of 10 plus the logarithm of 2, so that's 1 plus, so this is 10 to the power 1, 1 plus 0.301, so that's 1.301, and the logarithm of 70 is equal to the logarithm of 10 times 7, which is the logarithm of 10 to the power 1 plus the logarithm of 7. So that's 1 plus 0.845, which is 1.845. Okay, so let's add these on. So here we've got 20, which is 1.301, and 70, which is 1.845. And if we go further into this domain here, in between 100 and 1000, so how about the log of 200? So that's equal to the log of 100 times 2, which is the log of 10 to the power 2 plus the log of 2. So that's 2 plus 0.301, 2.301. The log of 700 is the log of 100 times 7. So that's the log of 10 to the 2 plus the log of 7, so that's 2 plus 0.845, 2.845. Okay, so we can add that on here, so that's about here, 200, 2.301, 700, 2.845. So I hope you noticed here, this 301 part stays the same. So the first part, but before the decimal place, determines what order of magnitude we're in. So 0.301 means that we're in between 1 and 10. And then if we multiply by 10, then it's the first part of the logarithm that changes. And you can see that we see the same pattern with the logarithmic values getting, the y values getting more and more squashed up on the number line as we get towards our round number. Okay, and obviously this could carry on, so 2000 would be 3.301, 20,000, 4.301, etc. So that's that first part. Now I'd like to, what happens if we go numbers smaller than 1, so our logarithms are smaller than 0. How about that? So, how about the logarithm of 0.2 now? So that is the logarithm of 0.1 times 2, which is the logarithm of 10 to the power minus 1 plus the logarithm of 2. So that is minus 1 plus 0.301, which happens to be equal to minus 0.699. So here the ending isn't the same, but we're kind of the same distance away from 0 compared to the 2. So here we've got minus 0.699, so that's 0.2. Then similar log of 0.7 is the log of 0.1 times 7, so that's the log of 10 to the power minus 1 plus the log of 7, so that's minus 1 plus 0.845, which is minus 0.155. So all the numbers that are smaller than 1 have logarithms that are negative, and again we see the same pattern of the numbers getting more squashed up as we get towards the round numbers. Okay, and then one last one, so log of 0.02 is the same as the log of 10 to the minus 2 plus the log of 2, so that's minus 2 plus 0.301, so that's minus 1.699. That's here somewhere. So I've got the same pattern with the same ending, but that's for all the numbers that are smaller than, all the logarithms that are smaller than 0. And finally the log of 0.07, so that's the log of 10 to the minus 2 plus the log of 7, so that's minus 2 minus 0.845, or minus 1.155. Okay, so that's a very important point, that this ending changes, okay? So we have to, yes, it's minus 1 plus 301, and that's why the ending changes, and that's an important point here.